Okay, folks, this last piece is going to be maybe the hardest part. And first of all, I want to change this problem. I want to change this to p of x is equal to -2. And what I'd like to do is, without using the graph of p, I want to solve this equation. So just like we did up above here, we're asking the question, what inputs give me an output value of whatever I'm setting this equal to? So for example, in this question here, we said what input values give me an output of 4? And if we went and we looked at the graph of this function, we wanted to have an output of 4 that was along this horizontal line here, and we found that that happened at the input x equals -2/3. That's what we found when we set the middle piece of this piecewise function equal to 4. Why was it the middle piece? Well, we kind of cheated a little bit. We looked at the graph and saw that the graph only ever intersected the y value 4 on this middle piece here. So for this problem, what I want us to do is we want to solve p of x is equal to -2, and we want to do so without looking at the graph of p. So when I have to do this without looking at the graph of p, I'm just going to go ahead and set each of the 3 pieces, or however many I have to this piecewise function, equal to this output value. So let's go ahead and do this. The first piece of this piecewise function was -2x minus 11. So I'm going to set -2x minus 11 equal to -2. And then the second piece of this piecewise function was this this line right here, 3/2 x plus 5, and so I'm going to set the 3/2 x plus 5 equal to -2. And then this last one, albeit is a little bit silly, like if you say this seems silly, that's okay, but in some cases this wouldn't come out to be nonsensical. So I'm going to go take this third piece, which is the output function -4, always whatever your input is, y equals -4, and we're going to set -4 equal to -2. So then I'll go through and I'll solve each of these equations independently. When I go to solve this equation, I get -2x is equal to, careful, adding over 11 would be +9. So I get x is equal to -9/2. And -9/2 is roughly -4.5, and if we go look up here, sure, at x equals -4.5, this first piece does indeed intersect the graph of my function. Okay? And so we'll keep that answer. That will be one of my solutions, and actually we'll find it's the only solution, but let's go ahead and just proceed. So my only solution will end up being -9/2, but let's see what happens as I set this piece equal to -2. This is what I'm trying to get at here, folks. When I go to set 3/2 x plus 5 equal to -2, that gives me 3/2 x is equal to -7, or that x is equal to multiplying this 2/3 over to the other side, or dividing both sides by 3/2, however you want to think about it. This gives me -14/3, and you can solve that equation on your own. Take your time to do that if you need to. But we get x is equal to -14/3. What's the issue here, folks? Well, -14/3, I'm not exactly sure. Let's see here. That would be about -4.67 is about what that value is, or -4.6 repeating. But notice, this is what I wanted to do. This is the whole reason for working this hard example. This pink or this red curve only applies for x values between -4 and 1. And when I went to solve this, when is the red curve equal to -2, I got a value that was not in the domain of that piece. This is not in the domain of the second piece. And so we are going to throw out that solution. That's what I wanted to go through, folks. That's why I'm working this example here. When I went and set, without looking at the graph, when I went and set the second piece of this function equal to -2, I got an answer of -14/3. Okay? As a decimal approximation, that's approximately -4.667, roughly. And notice that that decimal approximation, or that -14/3, is not in this interval. So even though I found a solution to the equation, the solution didn't lie in the interval that I wanted, so I had to throw it out. That's a tricky move, folks. I'll let you practice that. We're going to talk about that more in class. That's why we're reintroducing the idea of piecewise functions, is to get to something like this. So if you're finding this difficult, don't worry about it, but do please come see me with some questions, because I'd love to chat about it. Okay. Finally, this last equation is kind of silly. Notice this last equation has no solution to even check to see if the solution was in the domain. So my only answer is x equals -9/2. So give me just a moment to recap, folks. Here I was asked to solve the equation p of x equals -2. And I'm told I can't look at the graph here. So what I did was I went ahead and set all three pieces, the green, the red, and the blue, I set all three pieces equal to -2, and I solved each of these equations. When I solved the first equation, I got x was equal to -9/2, or that's about -4.5. But then what I had to do was I had to go look at the domain of that green piece. This was the domain of that green piece, and sure enough, the value that I found for x lies within that domain. And so I got to keep that answer of -9/2. I kept it. But when I did the same thing with the red piece, I got an answer when I solved the mathematical equation. But the answer wasn't inside of the interval for that red piece, and so I threw that answer out. All right. So the last thing I want to do is go back to the questions of the domain and the range for this function. And in one sense, there's nothing new here. We've done this previously before, where we've looked at a graph of a function and I've asked you to determine the domain. And one way to think about it is if you were to project this graph onto the x-axis, you can determine the domain. So you could think of taking this graph and smashing it onto the just the x-axis here, just along here, and asking the questions, which points on the x-axis correspond to ordered pairs on the graph of the function. And here you can see I've actually labeled the projection of the first piece in green and the projection of the second piece in pink or red, and the projection of the third piece in blue, I projected it up. So you could get the domain from the graph. The other way you could get the domain, though, and this is one part that is different, is I can go ahead and read the domain from these domain intervals, these separate domain intervals that I give for each of the three pieces for this particular piecewise function. That is, I can get the domain by unioning all three of those, or all n of those intervals together. So let's go ahead and do that here. We would have as the domain from -7 to -4. Bear with me here, folks. I'm going to fix that. Unioned with -4 to 1. Unioned again with 4 to infinity. Now, it's bad form when you list the domain. If there's no gap in the domain, it's bad form not to write those as a single interval. So I'd like to do that. The domain of this function would be from -7 to 1, unioned with 4 to infinity. If you were to write the domain this way, where you have a union symbol there, but there's actually no real gap, that's going to be misleading to your reader. So you want to go ahead and put that into a single interval, like I did right here. Then finally, let's ask about the range. If you were to project this graph onto the y-axis, we would find that the range of this function would be, remember we learned how to do a singleton point another day, a previous day, it would be from -4, and then we'd also have, again, from -3 to, oh, that's a little bit hard to see here. If we plug 5, or if we plug in the domain value 1 into this function here, that's into the red function, we'd have 5 plus 3/2, which is 6.5. So that's all the way up to, another way you could write that is as 13/2, and that's included. So there's the range of this function. We got the range by thinking about smashing the graph onto the y-axis. Notice that to get this point right here, maybe I could guess it by reading off the graph, but the surefire way is to take the number 1, that domain value 1, right here, and actually plug it into the function. Okay. Folks, I just realized I have an error. Hopefully this hasn't caused any confusion. This should have been, notice we do include this value 1 here for that endpoint, so that should have been less than or equal to 1, and we should have included this 1 in both of these locations here. So I'm so sorry about that. I hope that hasn't caused any confusion. Okay, that covers the domain and range of these piecewise graphs. The last thing I want to do is I want to mention that you have seen lots of piecewise functions before. And the most famous piecewise function is the absolute value function. And sometimes it's easy to forget that the absolute value function is actually a piecewise function. How does this function work? Well, we say that f of x is going to return one of two elements. It's either going to return x or it's going to return minus x. And it returns x if x is greater than, and usually we put or equal to 0. And it returns minus x if x is less than 0. So let's go ahead and practice that, folks. If I were to ask you to evaluate f of 5, this would be equal to, well, let's see here, which of the two pieces apply? Well, 5 fits in this interval, the first one, and so we just return the value 5. But if we were to do, say, f of minus 3, the second piece applies. Notice negative 3 is strictly less than 0, so the second piece applies. So we say that's going to be minus parentheses minus 3, which is equal to 3. And that's how we use the absolute value function as a piecewise function. Now, folks, of course, I know many of you are able to take the absolute value of a number without thinking about it as a piecewise function. But it's important to remind yourself that that absolute value function is piecewise, because there will be times when we get to calculus 1 where we will need to use this piecewise definition to move forward. Okay, folks, so the very last thing I want you to do in this written pre-work is to go ahead and repeat a problem. This is very similar to the problem that I had on the previous page, but I worked through it all with you. So I'd like you to repeat this problem with similar questions. They're slightly different graphs. You're going to give the domain, etc. So take some time, work through that, and then when you're done, go ahead and work the MyLab Math pre-work associated with this written pre-work here. That's all I've got for you, folks. Have a great day. We'll see you next time.